Here we're going to be taking a look at how does ax squared plus bx plus c equal to mx plus d, or a polynomial equal to a line. We're going to be answering the question, when can you recognize when to use a linear model or an exponential model? In this example problem, the left side is raised to a power and has a multiple of different terms in this expression. This is a polynomial, which we'll spend more time in later lessons on. To the right side, that 5x minus 6, that's a line, a linear model. Now, it would be easiest to see if this was on a graph. So I bring in this little piece of graph paper with these two lines graphed on them. By looking at this model, I can see that there's at least one, but farther up above the graph, there is a second point where they intersect. This means that the equation on the left is a polynomial model or an exponential model, and the equation on the right is a linear model or just simply a line. In the second example, we see a very similar situation. The expression on the left is a polynomial, and the expression on the right is linear. This means if I was to graph them using a table, lists of x values, I may stumble across the y value that makes this true to be able to find it. Another way to do it is to actually just solve for x, so that 3x squared minus 5x plus 6 is equal to 7x minus 8. I'll subtract 7x from both sides using the subtraction property of equality to get 3x squared minus 12x plus 6 is equal to negative 8. I'll then add 8 to both sides to get 3x squared minus 12x plus 14 is equal to 0. Now, we will learn how to do these problems and solve for x very shortly in polynomials, but right now it's good enough to know that I could graph these two to find where they intersect, and that I will learn how to solve for x to find those exact points. Math is so much fun that some teachers spend their summer doing it.